Good morning, everybody, or good afternoon. My name is Kouassi Mensah. I work for Oracle. I do product management for Java products. Today's talk is about the asynchronous and reactive database access, also known as ADBA. Here is our disclaimer, our legal disclaimer. Okay, quick agenda. We'll introduce some concepts and goals, design choices, and spend the rest of the recording going through the API, through code, and then we'll wrap up. So what is ADBA? It's a proposal to come up with a Java standard for relational database access API that never blocks user thread. Also support reactive stream processing with non-blocking back pressure where appropriate. We believe that we don't need reactive streams everywhere when we interact with the database, so where appropriate. So why do we need such API? Because database access is slow and you block threads for a long time, and which incurs scalability of your system. Now, we also want to bring reactive programming to the relational database. The ADBA has been proposed to the Java community, and we're working with some members of the JDBC expert group. There is no target date yet. So what are the design goals of ADBA? Primary goal, and we will repeat this all the time, no user thread blocks ever. This way we can minimize the number of threads used for database access. It is an alternate API. It's not a replacement or an extension of JDBC. The goal is high throughput application. In this first release, it's not a general purpose API. It's built exclusively on the Java SE class library. To be a standard, we cannot depend on third-party library. However, reactive streams libraries such as Reactive, AccessStreams, and RxJava may use ADBA underneath. Okay, so what are the design choices? There will be no reference to Java.SQL, which is the JDBC API. A rigorous use of types. What does this mean? Well, if you look at JDBC statement, you have statement.execute with a string as a parameter. This is a valid and it works. Prepare statement, which is a superset of statement, prepare statement, extend statement. However, with prepare statement and execute with a string as a parameter will compile but will throw an exception at runtime. So this is not a rigorous use of types. We'll support the build pattern, the Fluent API, Fluent programming. Objects are immutable after initialization, so there's no change. And one way to do things is enough. We don't try to come up with different mechanisms for achieving a goal. No SQL processing by the driver. I'll talk into that later. And obviously avoid the infamous callback hell. So what about streams? Java streams are ultimately blocking, so not an option. What about reactive streams? There is the reactive streams manifesto. On Java 9, Flow is an interface to support reactive streams. However, it has no implementation in the JDK. So the user thread has to do the implementation of the interfaces. What about Jakarta EE, also known as JNoSQL? This is for NoSQL database types, such as column type, key value database systems, document database system, graph database system. So this is definitely not for a relational database. What about the proposed R2DBC from Pivotal? So Pivotal, they support, they are the promoter of the Reactor library. On R2DBC is based on Reactor. It has a dependency on Reactor, which means you cannot use it for Arca streams or RX Java, for example. The stand is reactive everywhere. Unlike ADBA, where we think we don't need reactive streams everywhere when we interact with the database, R2DBC promotes reactive everywhere. So what about Java Fibers project Loom? This has a lot of potential promises. The goal is to reduce the complexity of writing efficient concurrent application. In other words, with Java Fibers, which supports what is called structured concurrency, you will not need to write complex asynchronous code. That's the promise. It's going to generate high throughput to existing application with minimal or no code change, because it's going to be supported within the JDK, so the application can benefit from Java Fibers without making significant changes. General availability is not yet well defined. I mean, it's more than a year ahead. So Java Fibers is coming, but it's not here yet. Okay, so what are the reactive programming mechanisms in Java in the JDK? So it started with Java 8 with completion stage and completable features. Those propose an event-based push model. It allows composing asynchronous tasks. It supports lambda expression and fluent programming. You can look at more detail on the URL on the slide. It is a very powerful. It comes with a lot of function, a lot of interfaces, a lot of function, some classes. So the interface is the completion stage, but the classes are completable features. And then in Java 9, there is this Flow API interface, or Flow API. The user must implement the interfaces in the user code because the implementation is not in the JDK, so you have to implement the interfaces. They are very simple, but you still have to do the implementation. What about HTTP2 client? It does indeed support requests and responses as reactive streams. However, it's not a substitute for reactive streams library. You cannot just use HTTP client and not depend on reactive stream library and achieve everything you want to achieve. So here is a picture to explain for people not familiar what the Flow API is. So you have two interfaces. One is the publisher, and the other the subscriber. So here is the Java user code, which usually would implement the subscriber interface, where you have to implement the onSubscribe method, the onNext method, the onError, and onComplete. Those are the 4 methods you need to implement if your Java code will be acting as the subscriber. In this example, ADBA will be the publisher. So ADBA has to implement the subscribe method. So the way the Flow API works is there is a subscription object which is passed between the subscriber and the publisher. So it will be used to tell the subscriber, I can consume more data, to tell the publisher, sorry. So the subscriber will tell the publisher, I can get more data, and the subscriber will send more data. So the whole purpose of reactive streams is make sure that a consumer can consume whatever you're sending him, don't send more than it can consume. And there is a control of the back pressure to make sure that you're not sending more data than it can support. We will have some example on how ADBA is using the Flow API to support reactive streams. Okay, time for code. This is an insert operation as you would do using ADBA. The difference between ADBA and JDBC is that in ADBA there is no statement, prepare statement, callable statements. Operations are defined by the type of result. So in this case, an insert operation is a row count operation because it returns a count. Okay. In this example, we have an insert into a table. We're going to insert the ID, the name, and the answer. Those are attributes of an item. An item is a POJO, which has ID, name, and answer. So we are setting the values for the ID, the name, and answer, and submit the operation. So the user could prepare and submit operations and return. The implementation or the driver will asynchronously execute those operations. So this is an example of an insert. It's a very simple insert statement. And here is an explanation of the way ADBA works. So everything that interacts with the database is an operation. For example, a SQL or other database operation, parameter assignment, result handling, submission, completion stage. Those are operations. The user threads create and submit operation. Submitting operation never blocks. Creating operation never blocks. So at the end of the day, the user code prepares, submits operation, and return. The implementation takes care of the execution in asynchronous ways. So for example, as you can see on the slide, it performs the round trip to the database, executes the result handling, and completes the completion stage. More code. GetDataSource. This is a convenience method, so it is provided already for you. You don't need to implement. We are just showing the code database factory. Get a builder, furnish the URL, furnish the username, the password, and build the data source. So this is the implementation of getDataSource. From the data source, you can get a session. And a session, there is a convenience method called getSession. And you can see here, the implementation of getSession is to get a builder, build the session, and attach. So attach is two things. Attach will submit what is called an operation group. I will explain an operation group later, but for now, a session is an operation group. Right? A session is not exactly a connection because a connection is already attached to the database, has already have a direct connection with the database. A session is something which will happen in the future. The connection to the database will happen in the future. For now, we submit the group operation, they submit, and then we submit the attach operation to place that session on the operation queue. So we have this submit to submit the attach operation, which is an operation itself. The whole process never blocks. Okay. More code. Here we have a select statement, a select SQL statement. Okay, this fragment of code will get some IDs, which is a list of integers from the database. So we get a try with resource block. This is very convenient. When you exit the block, it releases all the resources. This is not ADBA, it's a Java standard. Okay, so we get a session from the data source. We're gonna execute a row operation. So a row operation, because a select return rows. So insert returns a count, select return rows. So row operation for select statement. So the select statement here will recap the ID, the name, and the answer from the table, where the answers is equal a value. So we set the value for the target. We specify the type, and you will notice that we always specify the data type. But how do you handle the result from the operation? Upon the execution, you have to process the result. So this is a result handler. So the collect, we have a convenience method called collect, which is different from Java Streams collector that we will use. Anyway, from the collect, you have to provide a supplier and then an accumulation function. And here what we have is a list is the accumulator, and for each row, we will recoup the ID, which is an integer, recoup the ID and stuff that into the list. So at the end of the day, we're gonna return a list of integer as the result. Notice the type witness here. This is important for ADBA. We will always use the type witness. Okay, so you prepare, you set the value, you define the result handling, and you submit the operation. That's a select. A close operation also never blocks, and here it's never skipped because we need to close the operation group. So that's why we cannot skip the close. And I will explain what is an operation group later. What about SQL support? All SQL is vendor specific. For example, if we have an ADBA driver for Postgres, all the SQL statement will be Postgres specific. If we have an ADBA driver for Oracle, the SQL statement will be Oracle specific. When we say that, we mean the parameter markers. Okay, so as you can see at the bottom of the slide, different vendors use different parameter markers. You can see that DB2 used column, MySQL used the question mark, Oracle is the same as IBM DB2, Postgres used the dollar and a numerical value, SQL Server use @ etc. So processing the vendor-specific SQL to come up with a sort of a pseudo standard requires a lot of overhead and more complexity in the implementation. So that's why the decision was to not support vendor specific, to just pass through the SQL statement. So each SQL is vendor specific. There is no attempt to understand or reformat or translate whatever. Okay, now we will see a more complex example. Here we will return a completion stage, which is a list of items. So we have item for answer, which is the name of the function. Try with resource block to get a session. It's going to return a list of items after executing a row operation, because this is a select statement. So we will recoup the ID, the name, the answer from a table. We will set a value for answer. So we set the value for the bind variable. We specify how we want to collect the results. So here we have a Java stream collector mapping. So we are going to map a function for each row. So for each row, we create a new item by recuperating the row at the column ID, which is an integer, the row at column name, which is a string, the row at the column answer, which is an integer. So it's going to map this function to each row. Then we're going to stuff the result into another collector, which will produce the list. So at the end, we return a list of items, okay, and submit and get a completion stage. We need to return the completion stage, so we need to have the get completion stage. So that's an ADBA example where you're recouping a completion stage of a list of items. Okay. Now, let's talk about transaction. The problem with transaction in ADBA is everything is happening in the future, so you have no control on the outcome of the execution of the different operations that make the transaction. So you cannot, in a determinist way, write a commit or rollback. Okay, so what ADBA proposed is an object, let's assume this is a flag, that we are calling a transaction completion. So a transaction completion is an object which will carry the completion of the transaction. So based on the value in trans at the end of the transaction, we are going to commit or roll back your transaction. So let's see how it goes. So here we have a completion stage, which will return an integer. The name is ID promise, and that will be the result of executing a row operation, which is a select. Okay, so type witness, select statement. We need to set the value for the bind variable, so we set it to 1. Then we specify how we will process. So here we have the convenience method collect, which will be using the Java streams collectors, the collecting and then, so collecting and then will map this function, this lambda. So it will recoup the column empno, recoup the integer at the column empno, stuff it, and then send the list to another collector, which will create a list of that list of empnos. It will create a list, and then we will recoup the first element of the list here. So this whole thing is to recoup one ID from the list of integers. Okay, we set the transaction status on error. We set the status to set rollback only. We submit, we recoup the completion stage. That's first part of the transaction. Second part of the transaction, we have an update operation. An update, like insert, return a count. So we need a row count operation. We need to set the value for the bind variable. So we have the depth node, it's set to 50. the emp node is set to the value ID promise, which is the completion stage. So this value will be set when the first operation, the previous operation, will have been completed. By a count, if the count is not equal to 1, then there is a problem. We set the transaction, the flag, to rollback only, and we throw an exception. Otherwise, we return a get count. Okay. Next, if there was any error during the course of the execution of all the operations that make up the transaction, we set the status to rollback only. So you prepare, you submit. Then there is this catch errors, which is never skipped. And then the operation, depending on the status of trans, will be committed or rollback. The whole thing will be committed or rollback, depending on the status, the value of trans. So that's how you will use the transaction completion object to control whether you want to commit or roll back. I mentioned operation groups earlier when we were talking about a session. So a session is an operation group. So what are operation groups? Operation groups are a set of operations. This set has its own result handling, its own completion stage. You submit members, operation which are members of the group, submit to group, and submit the whole group as unit. So the order of execution could be sequential. For example, when you use a session as a group, you could, by default, a session is sequential, as here. So each operation will be executed sequentially. All the members of the group, which are operations, will be executed sequentially in the order of submission. You could specify that you want execution to be in parallel. Okay. Execution could also be conditional or unconditional. I mean, the operation group could be conditional or unconditional. The error response handling could be dependent, meaning the remaining group members are skipped, or could be independent. Remaining groups will be processed, will not be affected. For example, if you are printing checks and one operation fails, you're not going to stop the whole process. You continue cutting the check or printing the checks for the other employees. So as we said, a session is an operation group. By default, it is sequential. It is dependent, which means when there is an error, the remaining group are skipped. And it is unconditional by default. So let's see how we will use an operation group doing parallel update. So this parallel update, it's going to return a list of items. No, it's going to update a list of items. So we have the data source as input. We have a select ID from tab, and then we have an update. So we have two statements. We have the query, and we have the update. Okay. So we get the try with resource block, get a session within the try with resource block, specify the operation group. We specify that this is an independent. Independent means when one operation fails, we could continue to process the other. And in parallel, the order of execution is parallel, so it's not sequential. So we have, we have group submit. Group submit submits the operation group. And now we're going to submit the members of the group individually. So you first submit the operation group, and then you submit members of the group. Okay. So here we have for a list, for each item in the list, we get a list of items as input. For each element of the list, we get a completion stage, which will return an integer, and this integer is the ID promise, this is the same example we used earlier, but now we're doing things in parallel. So the ID promise will be the result of a row operation, which is the query, and you can see type witness and integer. So we return an integer into ID promise after executing the select ID where answer equal answer, right? So that's what we're going to execute. So we set the value for answer, which is a string. We set it as answer. And then we specify how we're going to collect. So this is a convenience method collect. It's made of a collector of. So this is the lambda, which will return an array list. So we take the list as the list here will be used to stuff in the rows, the ID, which is an integer that we recoup from each row. So from each row, we recoup the ID and we stuff that into the list, and then we return the list. Okay, so that's how we will handle the result from the execution of the row operation. So for each element, that's how this happens. So we're going to recoup one ID and stuff it into the list, submit the operation, get the completion stage, and then we recoup the first element of the list. So we get the list, but we recoup the first element of the list. So remember, we have ID promise, which is an integer, so the first element of the list will be set as the value of ID promise. And this will happen in the future because this is a completion state. So that's the first part of the parallel update. The second part will perform the update, which is, oh my God, sorry. The row count operation, which is the update, we set the value of ID to be the value of ID promise, which is the completion stage. We set the name, we submit the operation, we get the completion stage. If an error occurs, we complete exceptionally. So that's a parallel update. Okay. I think at this stage, you have a pretty good idea of how to perform select, SQL operation, insert, update SQL operation, how to process the result set, etc. So you have a pretty good idea of traditional operation with the database. We also went through transaction. Now I will show you where we support Flow, where we support reactive streams. Okay, so row publisher. This is a different operation than the row operation, which is to recoup the query. Here we know that we want to process the result as a reactive stream, so we use a row publisher operation. Okay, so what you see here is we have the SQL statement, select empno ename from emp. We specify a completion stage, which will get the result, and the completable future. We're going to implement the subscriber interface. So we get the Flow subscriber. We will implement, we declare a subscription object, which will be used between the subscriber and the publisher. Okay, so the end user code is the subscriber, and ADBA is the publisher. So we get a names, a list of an array list. The man is set to 0. We will implement the form method that a subscriber in a Flow API must implement. So unsubscribe, this is the first method that you call during a Flow operation, and we set the request to 10 to recoup 10 rows. So that's what unsubscribe does, and it's the first operation that you call. Then on next, which is the sort of main method in the implementation, that will be called every time next row. Okay, you can see here that we recoup the column, which is a string, at the column INE, we record the string at the column ID, and we add it to names. And if the demand is fewer than 1, we ask for more. So that's how you control the flow between the subscriber and the publisher. You request more because you are capable, you are able now to process more. Okay, so onNext must be implemented. OnError must be implemented to complete exceptionally. OnComplete must be implemented, and it just returns the list of names. Okay. And here is the user code, after having implemented the interfaces. This is your user code. This is the main part of the code, which is get a session and perform a row publisher operation with the SQL operation defined earlier, and then subscribe, providing a subscriber on the result, the subscriber object. Remember, the subscriber object will be used between the publisher and the subscriber. So you submit and you get the completion stage. That's how you would do reactive stream processing the result of the data from the database using ADBA. So that's one place where we use reactive streams in ADBA. The second part where we use reactive streams in ADBA is to control the submission rate. Submission rate, you submit compression. What if the session cannot process those things we don't want to accept, and then later tell you that we cannot process? So here is how this is done. A record subscriber will implement the subscriber interface. So we get an operation group. We define a private operation group. We declare a session. And then in the record subscriber, we get a session. Then we implement, so this is a function, record subscriber, which only gets a session from the data source. Then we implement onSubscribe, and you can see here this is an independent, and we specify how we're going to process the result using the convenience method collect, which itself uses Java Stream Collector. And we submit, and we specify request hook. This is very important. This is how you control the flow of the submission, the rate of the submission. So that's specified in the implementation of onSubscribe. Then we have onNext. OnNext will be inserting into the tab the values of the record. So we have a row count operation because it is an insert, and we set the record to be the item, and item is a POJO, remember? And then we apply get count to return the count because this is a row count operation. So onNext is implemented like this, OnError and OnComplete. So the only place where we specify that we want to do reactive stream processing is during the declaration or the implementation of onSubscribe, and by using the request hook. I can go back onto the slide, and you can see here, this is how we specify. And that will help, using the subscription object and also invoking the request on the subscription object. Okay, so that's the second place where we use reactive streams /flow in ADBA. The last place where we use flow and the reactive streams in ADBA is when we want to control the session creation rate. So session creation means I want to create session and I will execute operation through the session in the future. But what if your implementation or your database cannot sustain more session than you're creating? This is sort of pseudo or reactive connection pool where you want to control session creation rate, something happening in the future. Okay, so here we have an item subscriber which get the factory. Its factory is the data source factory. We have onSubscribe, and in the onSubscribe we get a builder from the factory, and we specify the username, the URL, the password, and we specify the request hook. Remember, we are creating sessions here. That's why we need to provide the data source and also the session, the information to create a session. So we have the host, the username and the password, and the request hook. This is the most important. Then we build the data source, and we implement the onNext, which is where you create a session from the data source. You get a session, and you perform an operation, which is insert an item, for example. Okay. So we also implement the onError and onComplete. This is the third place where we're using reactive streams in ADBA, and we think those are reasonable places where you would need reactive streams when dealing with database. To wrap up, we do have a proof of concept of ADBA that is using JDBC, which means not everything is non-blocking. Some features may block, although the Oracle JDBC team has done a lot of enhancement to make even AOJ, which is ADBA over JDBC, non-blocking at a lot of levels. Anyway, this code is available on the next slide. You will see it's available on GitHub. It's been released on the Apache license, been forked. There are other database vendors who have an AOJ support. I mean, they're playing with that. And here is what you need, you know, where you can see the conversation on the spec, where you can get the API, where you can get the AOJ and adapt it for your need or for your database. So this one is the Oracle database example. This is AOJ using the Oracle JDBC. Everything we say here is subject to change. So I don't know what's going to happen in the future, but this is where we are. And thank you again for attending, watching this video.